with Dr. Juan González Gómez from Universidad Politécnica de Madrid. So first of all, let's install the Adobe Reader. Okay, so first of all, why are robotics an important subject in education? They are useful because it is an interdisciplinary field that involves mechanics, electronics, and also programming. And these are very different fields, and robotics integrates all of them very well. So when organizing a robotic course, you can choose if you focus more on any of those subjects, or you just teach everything from building the robot to building the electronics or programming them. And when looking for a platform for a robotic course, we are looking for a reduced cost, since you want small groups of students doing more individual work. You also are looking for a platform that is easy to repair, since you will be working with a large number of robots. Then it's very probable that some of them will break, and then you will want it to be easy to repair, right? So another important feature is that it must be a flexible and expandable platform to allow not only basic education, but also more advanced research. So when looking for a platform, there are two main options. First of all, commercial robots, and the second option are custom-built robots. So as we have said, our requirements were that it should be a low-cost platform, and that is achieved more by the custom robots, because you can choose what to add to the robot, than a commercial robot that comes with some hard features that you cannot change easily. Easy to repair, so a custom robot, since you have built it, you have the ability to repair it fairly easily. But if a commercial robot breaks, you probably need to buy another one, and that's also affects the cost. And on the flexibility and expandability, also custom robots are more advanced in that subject. But then we need to ask two more questions. One of them is the industrial look that you get in a commercial robot. You can't get that industrial finish that commercial robots have. So with custom robots, you get a homemade look. You can see that clearly in the picture. And also, they are usually more complex, since you see all the wires here, it's a bit messy. And the biggest problem here is replicability. So you cannot mass produce custom robots easily. Traditionally, it has not been possible to do that. Instead, commercial robots, of course, they win in that subject, because you can just buy 20, 30 kits and just assemble them. So here is where Printbots come in. Printbots are a new kind of robotic platform that have been with us for 2 years. They have been evolving together with the open source 3D printing technology. And the key idea of these robots is that the parts required to build them, the parts for the main structure, are made with a 3D printer. So you have a design on your computer, and you can just click print, and it literally appears in front of your eyes. You download the design from the internet, and you can print it. It's kind of downloading a robot. So, as I have said, they have been evolving together with the open source 3D printing technology. These 3D printers, what they do is they are like traditional printers, but instead of ink, they use plastic filament, and they melt it, and layer by layer, they build an object. So maybe these parts take like 2 hours to print, but you just leave the machine working. You don't have to be hard working or cutting plastic, or it is automatic. This gives you the ability of replicate robots very easily, because you just need to add electronics, motors, sensors to a printed structure. So that simplifies the robot's manufacturing process. They can get as simple as required. You can also make a very complex robot that they can get as simple as required. And another important part is that since the designs are downloadable from the internet, they are a computer design, they are open source, they can be open source, and shared by the community. For example, there are websites like thingiverse.com where you can find printed parts for the robots. printed design. So this open source philosophy has given the robots the ability to evolve. So these Printbots have, since the first Printbot appeared, this is the mini Skybot robot, 2 years ago, many different variants have appeared on the internet. Someone decided to add a different wheel, they switched to a ballcaster, and I mean, anyone can add their own functionality. And that's a key part, because we were looking for a platform that was easily replicable, and it should have an industrial look. And these ones look more industrial than the first robot that I have shown you, but they are still custom robots, so you can choose what features to add to them. So this is great for our approach is to use these Printbots, these printable robots, in robotic courses, because it simplifies the organization. You can pick an already existing design and just modify it to adapt it to your robotic course needs. So instead of building it from scratch. So I wanted to share with you 2 personal educational experience using this new approach. First of all, my colleagues from Universidad Autónoma de Madrid decided, and I decided to organize a robotics introductory course at our robotics group. So we prepared some basic lessons for some engineering students, and we taught them the basics of Arduino and robotics. So some of the sessions were only for the electronic part, and the other sessions were the assembly of the robots and the programming. So and yeah, the robot, I'm going to talk about it in a minute. But the sensors that it has are light sensors and line sensors. So they program the robot to follow light and also a black line in the floor. So the robot. For this robot, we began from zero. We said, okay, at our robotics group, we have these materials. We had some Arduino electronic boards and some motors, wheels, and batteries, and also the ability to make circuit boards. So using these Printbots, we designed a printable chassis for the robot. Here you can see the printer working. This is like 20 minutes after it begins. This is one of the layers. So printing the chassis has allowed us to make five robots in less than a week after the first prototype was finished. But that's record time. I mean, 5 robots in a week without being every day just with hard work. We just build the electronics, which fits into the Arduino board. We already had the batteries and the motors. So we prepared the kits for the robots, for the robotic course in a week. So that was remarkable. So this was very important. So I decided to keep the problems that this robot gave us, because it was a bit messy. I mean, the light sensors fell off very easily, but I mean, it worked. For the course, it was right. But I decided to keep improving. So this summer, another personal experience is that I gave a small robotic workshop using the robot you can see over there. It's called the Arduino Skybot. So these robots took all the problems that I had with the other robot, and basing in the original mini Skybot Printbot that appeared, it allowed me to design the robot in a week. And a week later, I had built the 4 robot kits that were required for this workshop. So regarding the workshop, it was with primary students, so it was a different subject from working with engineering students, I can tell you. So it was much more basic. We the first day I showed them the Arduino board and how to the basic examples, how to make a LED blink, make some sounds, and each day I kept them building some part of the robot. Since it has a lot of parts, so they can just each day build a thing. So and they have fun. And it was a very satisfying experience to see that they were able to solve the problems that I proposed, because I gave them some code, but they made their own improvements. So it was, since Arduino is so simple, they love it. So the robot, regarding the robot, as I have said, it's called the Arduino Skyward, and it has many different sensors. It has this frontal is a distance sensor, so it can avoid obstacles. It has also two light sensors, so it can follow light, and line sensor to follow a line. And also it has a speaker. The kids had a lot of fun with the speaker. Yes, that was the best. I mean, I had them play some tunes, and I didn't knew they were going to be so amazed by the speaker. It was strange. So, and yeah, the idea, the original robot we used at Universidad Autónoma didn't have a distance sensor, and that was a limit. So I just picked the original board design and decided to put a distance sensor there. So that, and also the speaker that wasn't in the other robot design. So, so this robot, as I have said, was designed in record time, and most importantly, it was replicated very easily. In the robot we use at Universidad Autónoma de Madrid, we showed that it is possible to reuse materials and keep a very low cost. So here, it was also the case, because these 4 kids that were in the robotic course, they already had an Arduino kit, so that their parents had bought to initiate them into electronics, but the kids were like, okay, yeah, I can make LEDs blink, that's cool, but I mean, they didn't knew what was the Arduino. But now with the robot, they saw that it is possible to do real robotics with this board. So a key part is that you can reuse the available resources to keep the cost very low. So Printbots are great. You can use them in the robotics workshops, and we have focused on 2-wheeled robots, but anything is possible. I mean, the only limit is your imagination, really. I mean, these are a few of the robots that have evolved. This one has tracks, and this one has more tracks. I mean, it just this is an hexapod robot, and also a snake robot. So not only for simple robotics, but also for more advanced algorithms. So as a conclusion, the small effort that is now required using Printbots to set up robotic courses. This approach works. We are not restricted to use commercial platforms anymore, and also we don't need to spend much money or hard work just to build the robots required for the sessions. And using the available resources in this crisis time. That's very important. And it has shown to be a new way of technological education. So if you want more information, you can visit our websites. And also, I'm glad to answer any questions that you have.
Any questions for our inventor over here?
Yeah.
From Nigeria, I'm just interested in knowing whether you have your lecture notes on robotics on your website for us to have a look.
Yes.
Introductory work is on your website.
I have uploaded all the resources I use in the workshop. So all the slides and all the information.
Yeah.
The design is also in this website called Thingiverse, so anyone can download it. All the designs, I publish everything. So.
Thank you.
You're welcome. Yes.
Yes, you talked about a low-cost educational platform. How low would be the cost of producing one of the robotics for a school that in the rural areas deep in Africa?
So that's a very good question. It's very difficult to measure the cost reduction in this workshop, because I'm assuming that the cost of the 3D printer is zero, but that's not true, of course. I mean, you initially need to invest on the 3D printer, but the good thing is that they are open source and they are very low cost, and they can be reused on any kind of robotic course. You can even leave a course on 3D printing, because it's a very new technology. So the reduction of the cost is difficult to measure, but I'm sure that that you will use the 3D printer, I think the long term is this cost effective. So any other question?
Any more questions? I have a bunch of questions, but I'm going to leave them for offline. Thank you very much. So our next speaker is Dr. Manuel Montenegro of the Universidad Panamericana of Mexico, and he's a professor and researcher in the civil engineering department. He holds a master in hydraulics